Vanakkam. Welcome to this course on biomedical instrumentation. We started looking at ventilators. In this video, we will look at operation of a ventilator, some critical parameters. What are some critical measurements of the ventilators, both on the ventilator side and on the patient side, and some of the control variables for ventilators. Then triggers in ventilators, what are breath cycles in ventilators, and what are the types of breaths with respect to the ventilation concept. These are some of the constructs of ventilator technology. We gave this as input to AI and the image has been generated, but of course the input is given by us. Okay. So, first is you need to define what a breath is. We already did this in the previous in one of the previous videos. What is a breath? Breath is a cycle that is composed of an inspiration and an expiration. One inspiration, that is one time when you take air in and one time when you breathe air out. This is called as a breath. Okay, this is a fundamental unit of ventilation. This is inspiration plus expiration, the cycle. This is called as a breath. One breath is not just taking in, it also includes expiration. Okay, that is breath. What is an assisted breath? Assisted means what? Assisted is the breath that distinguishes patient effort versus machine efforts. So, that means there is going to be some assistance, some help, some support that is provided by the ventilator machine, the system. Okay. So, this essentially is a difference between regular breath and the supported breath. Okay. Essentially, the ventilator amplifies the need for the patient's requirement for breath and then provides the appropriate ventilation. Right? So, that is going to the difference as an assisted breath. Okay. Third is specifying the method or the means of assisting the breaths based on the control variables specified by the equation of motion, by the specific equation. What is this equation? What is the governing equation? We said that this is P muscle plus P ventilator is volume times the elastance plus flow times the resistance plus the auto peep that is there, plus the, let us say, peep. What is peep? Positive and expiratory pressure. Okay. This is the governing equation. We saw this in one of the previous videos, is it not? And we also provided a simpler version of this. For example, that is the governing equation, right? So, this is the governing equation. The simpler version is EV times RV dot. That V dot is flow. Remember that V dot is flow. Flow times I have said F times R. Instead, I will say V dot times R. Just so it is clear and we are consistent. Now, your ventilator control system must solve this equation in real time. Every instant, your ventilator control system must solve this equation and provide the appropriate ventilation that is needed. Okay. So, that is the next step, next construct, which is essentially the means of assisting the breath based on the control variables. That. Fourth is classifying breaths in terms of how inspiration is started or stopped. Is it that the patient is beginning to breathe, or is it that the ventilator is providing, or is it that the patient is beginning to breathe and the system is supporting, right? So, you need to decide the time at which you will provide the ventilation, so that there is some sort of synchrony. It is not like one ventilation after another comes in quick succession followed by a gap. You need to be appropriately synchronized with the patient's requirement. So, this is a synchrony is needed, so that two breaths do not follow each other too quickly or are not too far apart in time. So, you need to decide, this is critical for patient comfort, otherwise it will cause patient discomfort. Too much air can also cause patient discomfort, too much food can also cause, is it not, like too much food can become poison, too much air can also cause discomfort to the patient, which is also not a good situation. Fifth is the need to identify ventilator versus patient initiated start and stop events. That is a situation in which you want to say the patient wants to start to breathe, rather the machine wants to. Remember, depending on the control algorithm, it is useful to have which breath was started by who, whether the patient started it or the machine started it, and having a documentation of that, identifying which are the ventilator controlled or ventilator initiated events and which are the patient controlled or the patient initiated events. For detecting patient intention, nowadays you use electrical activity of the diaphragm muscle, for example. Is the patient attempting to breathe? You can use EMG type of input to decide whether the patient is attempting to breathe. Now that will be modern neurally controlled ventilators. Now that is a modern application that you could have, so that you know whether there is any electrical activity in the muscle at all, in the diaphragm muscle at all, so that you can decide whether the patient is breathing or whether the patient is initiating or the machine is initiating. The next is defining spontaneous breaths and mandatory breaths. Now this is critical to decide when to wean the patient from ventilators. When the patient is attempting to breathe, you want to remove assistance slowly. You see, as with children in life, with adults, for everybody, the more and more you provide, the more and more you spoon feed, the less likely they are to be independent. It is a broad statement, I am saying this with a broad brush. For example, in this course, the more I spoon feed to you, the less likely you will learn. That means my job as a teacher is to inspire you to learn. You must do the work. Then you are asking, what is my job? Well, my job is not to put things into your head. My job is to somehow make you think, inspire you to learn. Likewise, in this case of ventilators, by the way, this is also the principle I use in my courses at IIT Madras. In all my courses at IIT Madras, I almost never teach. I force the students to learn, or I kind of inspire, I kind of create a spark that will force the students to somehow check what is it this guy is speaking about. There is a difference. There is no way for me to put things into a student's head, or there is no way for me to teach students something that they do not want to learn themselves. I am not a magician. Likewise, with my research scholars also, I do not provide information that they do not request. Only the minimally provided guidance or assistance is what is provided, then they will do the work on their own. Likewise, coming back, we have digressed sufficiently, coming back to the ventilation part. In ventilators, the ventilator support must be minimal, so that the patient will attempt to breathe. You need to decide when to wean the patient from the ventilators, so that the patient can go on their own, because ideally and eventually the patient will have to get out into the society and become independent. Now that is critical for the patients. Now next is defining breath sequences. You need to decide what is continuous, mandatory ventilation, CMV, or intermittent, mandatory ventilation, IMV, or continuous spontaneous ventilation. You need to define these sequences. Okay. and then you need to describe the target schemes, continuous spontaneous ventilation. Okay. The other is to decide a target control scheme. This could be set point, could be some hybrid, or could be a servo, could be adaptive, etc. That is another thing that you need to decide. Then you need to construct a taxonomy, a set of all names, right. Create a standalone language in which this will work, right, for describing the ventilation modes, what type of control variable, what type of breath sequence, what type of targeting schemes, all these things should be part of your language. A single one of this cannot completely describe the situation. You need all of this, or you need more than one of this, right. What are some of the important measurements in ventilators? On the ventilator side, you have maximum pressure, of course you need to control the maximum pressure. Then you have PEEP. What is PEEP? Positive end expiratory pressure, of course, and then the difference, delta pressure. We discussed these. Then you have flow that you can control, inspiratory flow that you can control. Note that expiratory flow is not controlled, expiratory flow is a passive process. Then you can control volume, tidal volume, maximum volume, and then rate of respiration in the manual mode. Then you also need to humidify the air a little bit, okay. Cannot be dry or too much humidified. Has to be, there is an appropriate range in which it has to work. You have to humidify the air, and then the amount of oxygen. It's not pure oxygen that is sent, nor is it the regular this. So you control the amount of oxygen through this fraction FiO2. These are the various measurements on the ventilator side. Then you have on the patient side too many variables. We have seen some of these. Maximum airway pressure, among pressure, there is maximum airway pressure and the expiratory pressure and the delta pressure. Then there is flow, inspiratory flow and expiratory flow. Note in this case, expiratory flow for the patient is a parameter, just that it is not controlled by the ventilator. For the patient, everybody has to expire, everybody has to breathe air out. Right. Then volume, there are different volumes, tidal volume, expiratory volume and the respiratory rate that is there. And then compliance of airway, resistance of the airway, we discussed this because these are fundamental parameters in your equation, governing equation. Then the carbon dioxide level, then flow itself, inspiratory flow effort and the expiratory flow effort and the SpO2 level. Recall what is EtCO2? This is the end tidal carbon dioxide. Is it not? We mentioned this in a previous video, just reminding you. This is the end tidal carbon dioxide level. What are the various control variables? Mainly there are two control variables in ventilators. One is the pressure acts as a control variable. There are waveforms, these pressure waveforms are adjusted. Ventilation cycle, essentially once the pressure reaches, ventilation cycle makes sure that the pressure reaches the required value or the preset set point, set value. In this case the set variable is pressure. So volume and flow will change according to the mechanics. So one is an emergent phenomenon, volume and flow are emergent phenomenon, pressure is actively controlled in this case. So you need to also make sure that a minimum volume is delivered, right, so that there is effective and efficient ventilation. So if you look at the governing equation, if pressure is the set variable, then volume delivered depends both on the compliance of the lungs as well as the resistance of the airway. Recall what is this governing equation? The governing equation is this, right, not. In this, if pressure is set as the variable, then there is both compliance and resistance that come into the picture that will define how much volume of gas is delivered. So, it is dependent both on the compliance of the lungs as well as the resistance of the airway. Then you have volume control. In this case, it is the volume that is a set variable or the control parameter. Then a preset tidal volume is delivered during ventilation. A given amount of, given quantity of gas is delivered. In this case, you need to of course make sure that the maximum pressure is not reached. You set a safe value for pressure above which the pressure should not go. Maximum pressure limit is adjusted for safety purposes. Right. In many of the volume controlled cases, volume delivery depends primarily on compliance, right, or elastance. Yes. Elastance is inverse of compliance of the system. So, recall in the pressure case, it is dependent both on compliance and resistance. In the volume case, it is dependent primarily on elastance. Right. Then, what are the triggers that may be used in ventilators? The trigger variable that is used in ventilators might be to initiate the inspiratory phase during breath cycle. If there is a negative inspiratory pressure and negative inspiratory flow are there, these are used as triggers to initiate the inspiratory cycle. There is also a time window that is used as a trigger for mandatory ventilation. So, there is negative inspiratory pressure and there is negative inspiratory flow, but the patient is not breathing. Then the system waits for a given time, after which the system takes over and provides a mandatory breath, especially in intermittent mandatory ventilation mode. What is the other mode? Continuous mandatory ventilation mode, of course, CMV mode. Right. Then there is a CSV mode, which is continuous spontaneous ventilation mode. Check all these things. If the patient does not initiate, then the mandatory breath is provided. Then trigger window. In this case, the time period that is composed of for the entire expiratory time minus some break time, some refractory time is required to reduce the risk of triggering another breath, right? A breath before exhalation is complete. Before you finish exhalation, before you finish breathing the air out, another breath is sent. To avoid this, the entire expiratory time plus a little bit of extra time is given. If a signal from the patient that is given indicating that they want to breathe more, indicate an inspiratory effort, how will you find this? Using some form of biofeedback. Modern day method may use EMG type of electrical measurement from the diaphragm muscle, for example. If the patient indicates that they want to breathe the next, if it occurs within the time window, that means that the expiration has already completed, the exhalation is already completed, the patient is not going to breathe further. Breathe out further. So, that means that the patient is ready for the next breath. By the way, there are different forms of breath, you can breathe very fast or you can breathe very slow. So, there are different rates at which this can happen. So, inspiration starts if the patient has given a trigger, and then this is a patient triggered event. Okay. And then what are the breath cycles? So, you are interested in ending the inspiratory cycle and then starting the expiratory cycle, but the expiratory cycle is not a active process. What is the cycle variable? Usually pressure or volume or flow or time that is used to end. At what time or at what point will you end the inspiration? Some cycle variable. Then there is machine cycling. The ventilator controls the breath cycle and initiates the expiratory cycles. Once the set variable is reached, once a set variable for one of these parameters, if a set point is reached, then the ventilator will control the breath cycle and initiate the expiratory cycle once that is reached. Then there is patient cycle. In this case, inspiratory phase is initiated by the patients and ended once the set value is reached, the patient then the system will stop the inspiratory cycle. But the trigger itself, the initiation, the beginning will be set by the patient. Okay. What are the types of breaths? There are different types of breaths. One is a spontaneous breath. There are two control variables essentially. What type of breath? First is spontaneous breath, a breath for which the patient retains almost the entire control or substantial control during timing. How they want to breathe, they are able to do it themselves. This is called spontaneous breath. This means the start and end of both the inspiration, both the start and the end are determined and controlled by the patient independent of any other settings, okay. Especially for the inspiratory time and the expiratory time, that is patient both triggers and cycles the breath. This is a situation in which the patient is almost independent and almost weaned. This is a weaned patient, maybe, or a patient with less pathology. Then the mandatory breath, this is a case for which a patient has lost control. The patient is not breathing, they are not having any control over timing. This means a breath for which the start and end is defined by the machine, by the ventilator, by the system, independent of the patient. So, the machine triggers and cycles this breath. Then you have assistive breath. This is a case in which part of the inspiratory or expiratory flow is generated by the ventilator doing the work on the patient, right. In other words, if the airway pressure increases above end expiratory pressure during inspiration, if the airway pressure increases above the end expiratory pressure during inspiration, then this inspiration is assisted, as in the pressure supported mode. So, this is the case in which there is a trigger, the patient initiates the breath, and then the airway pressure increases above the end expiratory pressure, in essentially providing assisted inspiration. Okay. So, with this we come to the end of this video. In this video, we looked at the operation of a ventilator, some important parameters and some important measurements both at the ventilator end and at the patient end. Some of the control variables, what are the triggers and what are some of the breath cycles, and define some basics of breath cycles and types of breaths in ventilators. With this, we end this video. Thank you very much for your attention.